Welcome everyone to today's webinar titled Indoor Air Quality Topics. I'm Samel Harbison with an SAME national team, and I will be assisting with any technical issues you might experience today. Before we get started, I would like to go over a couple housekeeping notes. You have entered into the platform in a listen-only mode, but we ask that you double check your phones and microphones to make sure that they remain muted. Throughout the presentation, you are able to ask your questions in the Q&A tab in your toolbar towards the right of your screen. You may download today's presentation from the handout section in that toolbar as well. This webinar will be recorded and will be posted on the SAME Health Engineering Task Force webpage at a later date. And without further ado, I would like to turn it over to our moderator for today, Elisa. Hammer, you now have the digital floor.
Very good. Thank you very much, Tamel. I always appreciate your support. Welcome, attendees, to the Indoor Air Quality webinar put on by the Health Engineering Task Force. I'm Lieutenant Colonel Elisa Hammer, one of three co-chairs of the Health Engineering Task Force. I am also a member of the San Antonio SAME post, as well as the Leadership and Mentoring Chair. Today, we will be bringing in our Air Force SMEs to discuss indoor air quality. I can't wait to introduce you to them. We have a combination of bio-environmental engineers as well as civil engineers. And normally we converge on indoor air quality topics as we manage our everyday business. Before I get started and before I introduce our panel members, I'd like to run through this poll just to see who is in the audience. So if you can take a look at that poll, our questions here. Who do you represent? Are you active military, a civilian at a government agency? Are you a small business, large business, or are you from an academic institution or nonprofit? So the poll, I believe, is going to open up. I believe it's opened. I'm not quite sure. Well, I might need some assistance. Oh, here it is. Okay, I do see. Yeah, we're going to give it a few seconds.
The second poll just opened up, but if the results for the first poll is we have 36% at civilian at government agency, and then second we have active military, and then a couple for small business, large business, and academic institution.
Excellent. Well, thank you very much all for joining us. This is really exciting just to see who you all represent. Right now up on the screen, you'll see poll number 2. So now we want to know, what functional area do you work in? So go ahead. That poll has already started. And I think the numbers stopped moving. So I'm going to read the results here. We have 68% from the design and construction, followed by 27% public health, bioenvironmental engineering, industrial hygiene. Thanks all. Thanks for joining us. And 5% technology, research, and manufacturing. So that's very awesome. Thank you so much all for participating in that poll. That gives our speakers just an idea of our audience. Now with that, I'd like to introduce you to our speakers. Again, we have 3 speakers. Our first speaker is Lieutenant Colonel Alan Hale. He is the Radiation Health Chief at Air Force Medical Readiness Agency. He's a health physicist and certified by the American Academy of Health Physics. Today, Alan will be discussing the new Department of Defense radon policy goal and occupational exposure limit. He's also going to address the overall health risk and advantages of this new policy for both residential and non-residential settings. So a little bit of fun facts here for you. Our next speaker is Mr. Jim Works. Jim is an Air Force Liquid Fuel Systems engineer. He's a former Air National Guard base civil engineer and bioenvironmental engineer. He's a retired lieutenant colonel of the Air Force. Since 2016, he's been working for the Air Force Civil Engineering Center. He's currently our Air Force Fuels, Plumbing, and Vertical Transportation Equipment subject matter expert. Jim is a professional engineer licensed in the state of Florida. He's a project management professional and a cost-certified engineer. Jim is my go-to person as a bioenvironmental engineer. He is my go-to person for all things mold. So thank you, Jim. Mr. Tom Adams is an Air Force mechanical engineer for the Civil Engineering Center. He has 3 years of professional engineering experience with 37 in the Air Force. He has a 20-year military career, beginning as a communications officer out in Alaska in Elmendorf, and then ending as a civil engineer operations officer at Tyndall, where he currently works as a senior Air Force facilities mechanical engineer at headquarters Air Force Civil Engineering Center. He is a licensed engineer in the state of Arkansas and Florida. So without further ado, I'm going to hand the digital floor over to Lieutenant Colonel Alan Hale. Thank you.
This forum to talk about radon. As you can see, I'm going to do a radon review and provide some updates. Thank you for the kind introduction. I work up at the Air Force Medical Readiness Agency in DC. Here's my standard disclosure statement for this public forum. And this is what I'll be talking about. I'm going to talk about the new radon policy that was recently released and provide some radon review about units and why that's convenient. Talk about residential and non-residential examples, and then summarize it all for you. So in April this year, the Department of Defense Instruction 6055.08, which is the occupational radiation safety publication, included radon for the first time. Please note that this is only for occupational and not residential. And it set a goal of less than 0.8 working level months in a year and set an occupational exposure limit at 4 working level months per year. Why this is important is the NRC, OSHA, and different bodies have different standards or guidelines, but they weren't consistent. And DoD over the decades has not had any goals or set an OEL. By default, we've gone to various organizations. We must comply with the NRC and OSHA, but there are some disparities in there which cause some confusion. Moreover, the Air Force, the Army, and the Navy also interpreted some of the standards a little bit differently, which can and has been problematic at certain bases where joint basing occurs, including housing. In particular, the Air Force, in our policy, Air Force Manual 48148, our radiation protection regulation, we also adopt the goal of 0.8 working level months in a year and for the OEL for both our residential settings also. So as I talked about, the goal and the OEL are in the terms of working level months. I think most people are familiar with the picocuries per liter. EPA has a guideline, sometimes referred to as standard of 4 picocuries per liter. But embedded in that 4 picocuries per liter, there's an assumption on occupancy and equilibrium factor. And the occupancy and the equilibrium factor, given those assumptions, provide 4. However, if you work it back, the more important unit is actually working levels, or which can be translated to working level months. And it's interesting to note that the original EPA guidelines were both given in the terms of working levels and picocuries per liter, but throughout the decades, the working levels and the working level months in the EPA have dropped off. And I think one of the reasons why that is picocuries per liter are easy to understand. That's an activity per volume, where working levels and working level months are a little bit more difficult to understand. That being said, there's limitations in working with picocuries per liter, and you cannot scale them and make them equivalent for residential and non-residential settings. So moving on to working levels, you can see the definition of there, which is really drives at what damage can be done by the potential alpha energy. And given a set of factors, if all the radon progeny are in equilibrium with radon 222, which is actually your picocuries per liter measurement, you can get a working level. And as you can see, a working level month takes into account 170 hours over a month. Now, I know this can be confusing, but thankfully there's an equation to explain all this, because we're all scientists and engineers and we like equations. So if we have a concentration in picocuries per liter, we can use an equilibrium factor, which is unitless and by default is usually 0.4. However, it can be measured in the field if necessary. And then we need to know how long an occupant is exposed, our time in hours per year. And then by using a standard conversion factor in the denominator, we can equate a picocuries per liter to a working level month per year. So let's jump into an example. So if we have a residential housing example, and we assume that they have 100% occupancy, which would be 8,760 hours per year, and we already measured it at 4 picocuries per liter, because picocuries per liter are easy to measure. You need special equipment to determine a working level or working level months per year. We can use that 4 picocuries per liter, use the standard equilibrium factor. In this case, we use worst case occupancy, and we can see that the 4 picocuries per liter is approximately equal to 0.8 working level months per year and meets the goal. Now let's look at a workplace example. So let's say we have a building. It could be an office building or some kind of work center. And we measure 16 picocuries per liter. A lot of people historically would have used the 4 picocuries per liter and say that we need to remediate this facility. However, this is very conservative, and not understanding that the workers are not exposed for 8,760 hours per year could lead to mitigating something that truly isn't a hazard. So as you can see in this example, with 16 picocuries per liter over 2,000 work hours in a year, we can actually see that this facility and the radon levels actually meet the DoD goal. So the new DoD policy gives clear guidance to the radon program. It's our first step to overhauling the radon program to make sure that the services are aligned and harmonized to move forward with continuing joint basing issues. Now we can compare apples to apples, as it were. Before it was difficult to, for instance, in subterranean munition facilities, it was difficult to explain to somebody through risk communication why 10 picocuries liter was okay, but in their house it was lower. Where this, by having everything in the same units, that risk communication isn't as necessary. However, using the new goals, it's protective of health. As I said, the future work is to harmonize some of the mitigation timelines, because in our individual service directives, the mitigation timelines are not equal. And moreover, this is only for occupational at this point, although the Air Force has adopted it for housing also, and we hope to move towards that end. In the 30+ years that we've been working radon issues, the majority of the facilities that have been problematic or elevated have been identified and mitigated, and we're continuing just to redefine and tweak our program as we move into the future. Along with that, new construction standards over the decades have averted any potential impacts also. For our ventilation experts, generally when something is found, we usually do sub-slab ventilation, and by providing a negative pressure under the slab, we can vent through above the roof line and not allow the facility to entrap and close and concentrate the radon gases, which are problematic for worker health. Sometimes as we're waiting mitigation techniques to happen, because we realize there's funding things that need to be done, and also usually this work is contracted out. A lot of times by simply increasing the makeup air, we can decrease those concentrations, or by doing simple things like periodically venting the building through opening windows if possible, we can decrease the levels to meet our goals. With that, I'll turn it back to Colonel Hammer. That's the end of my presentation, and I look forward to your questions later.
Thank you, Lieutenant Colonel. That's a great introduction to radon and the new DoD standards. Really appreciate that. I did write in the chat, if anyone has any questions, please do enter them in the Q&A tab, and we'll be sure to get to them at the end of the briefings today. So up next, we have Mr. Jim Works of the Air Force Civil Engineering Center. He'll be discussing the Air Force processes and procedures and guidance for handling mode concerns. So over to you, Mr. Works.
Good. Well, thank you, Elisa. I'm also active in a post here. I'm about to become the president of the Panama City Post, so and always in the membership mode. That those of you who are not members of SAME, feel free to join us. Don't get scared, especially those who are not in the engineering side. The engineers, not a big E. We are inclusive to everybody, so I throw that in there. All right, so today I'm going to talk about how we got to our current mold stuff. It is more of a awareness, and just like the radon mitigation, there's a lot of things that people are concerned and try and ask questions, and that's driven a lot of our stuff. So slide, please. So I'm going to talk about our history, talk about how through the concerns of the public, through the government side, that we've gone and modified our design criteria and the unified facility codes, how the Air Force mold remediation has gotten to things, and just talk about certain cases of the contingency locations that we have challenges. So next slide. So in the early 2000s, and you started getting after the TV news stuff showed, here's black mold, everybody's dying, and the panic that got out there for a relatively small issue, but the world sees mold, and we're in our current world. And as I learned in my first day of my bioenvironmental engineer course, The science isn't necessarily the case. It's what the messaging is, and because the sensational news got there and mold, the world panics and got through things, and there are things we've appropriately not dealt with. So in 03 and 04, the DoD had, and the Air Force in our case at that point, we hadn't quite gotten into the unified facility criteria. We had engineering technical letter says, here is the criteria of how we prevent mold in our Air Force facilities starting up. So we created that technical guidance that was then implemented to all our design construction. And we had different policies, and the every time somebody saw mold, they would call the bioenvironmental engineer shop and say, hey, you need to come test this. And we proved out that that was not a valid use of time, because it really didn't matter whether I was my strep or whether I was the common molds, but the fungi would still cause the issues and could be the irritants, not necessarily deadly, but you're still having the problem. But what the, so in May 2005, there was a letter, the interim policy guidance for prevention, surveillance, remediation, and water damage associated mold contaminants for Air Force facilities. A key thing of that was a partnered document signed out by the Assistant Surgeon General for Healthcare of Operations and the Civil Engineer of the Air Force. So you have 2-star generals signing off and saying, here's how we're working together as the bioenvironmental health scientist professionals and the facility side of the equation to address things. They highlighted that, yes, mold happens. It occurs everywhere. And the biggest challenge that causes it is your water-related damage. And how do we get ahead of that and take care of things by controlling moisture, either in our design up front or in our operations modes? Explained all the roles, said building managers, facility occupants, including military family housing, the civil engineering, various functions in that there, and then what the medical treatment staff, from the physicians to the bioenvironmental engineers, and how we would do the process. So we said, here is the Air Force policy. And we went through there. Go forward about 10-ish years or so. In June 2016, the Air Force rescinded the ETL 03 because we finally incorporated the requirements that we put in as there for putting in a properly ventilated system, looking at your mold concerns in the architectural things. So we put those into the United Facilities criteria. So all DoD put that in there. So we didn't need our letter anymore. Next slide. And at the same time is when the Air Force SG-37 said, hey, we need to address our concerns from the medical side. So they pretty much took the portion of the addendum that was in that 2005 letter. It'd been many years since we updated that, and people were confused. So they went there and said, here's how you're going to deal with this, the medical service providers. We also had a highlighted issue of mold and concerns overseas. The DoD Inspector General had gotten some congressional input to go over and look at LUD and conditions that were there, which had to be mitigated through things. So there was a heightened awareness. So what that letter said is to the health professionals that if a physician determined that there were occupational health concerns due to the fungi of the area, that it might be appropriate for the bioenvironmental engineers to go out, use the technical guide for indoor air quality surveys, and see if that was a condition, and that would relate to that. Around the same time is when Air Force Manual 48-146 Occupational Environmental Health Program Management was up for rewrite, and the it came across our office for looking at, and to address and what they kept in there was the mold special assessments, which is very similar to what you'd use the technical guide for. And we had removed the civil engineer side of the policy. So, because it really didn't belong as an addendum in the 48 series. In doing so, we really didn't have a document and how we were restructuring guidelines. So in the Air Force operational side, we have playbooks, which are not a Air Force instruction level, but it's how a base can operate to do things through their operation maintenance. So we took the documentation that was in the 2005 memo, put it in this playbook for our operations folks to use that going forward. So that is what pretty much, and those are based on, and I'll get into that in a minute, EPA guidelines of how you clean and remediate once you see damage. Okay, next slide. So currently in our Unified Facility Criteria, the UFCs, the big driver is in 1200.02, which is the high performance of sustaining building requirements, where we do look for the making healthy people, and we're guiding there to do things. So there is a section both in the 2 and 3 which talks about indoor air quality, specifically the moisture control. So we want to establish and have a moisture control strategy for the building, whether it's ventilating, whether it's properly sealed envelopes, our rain gutters, whatever the case may be, that we look at ways to have that flow and condensation to prevent building damage and have that mold contamination. Because a lot of our challenges are, it's usually the stuff that grows in between walls, either a leak that's run down from a ceiling, a roof, condensate off of a pipe, of a chill water pipe. So we have those challenges. So the idea is to meet that moisture control and have that plan, and make sure that we have things sealed up and we don't have other leakages or other spots as part of their construction management plan. So that is a design that goes into the construction documents. The architecture has a section there in the best practices of how to address moisture control, make sure that it's smart, and again, be there. And then we get into UFC 341001, which Mr. Adams will be talking about here in a minute. His bread and butter document, the heating, ventilation, air conditioning systems. In chapter 3, we talk about ventilation air, and one of the things that the Tri-Services determined years ago to address the moisture in the air was requiring the use of direct outdoor air systems, where we basically get the air coming into the building to a relatively neutral state, so we've gotten the moisture out, so we don't have a lot of stagnant moisture in the air. So when it wants to sit on surfaces and inhibit that moisture, which then, as we know, in shady spaces grows mold spores. So taking care of that. Next slide. Oh, did I freeze?
I think I froze. I apologize. Sorry.
No problem. Sometimes my Wi-Fi doesn't play nice. So the CE playbook, what we did there, it's a tool for the operations flight, facility, and housing managers to facilitate the mold remediation. And especially when we have the case of privatized housing, you have the housing manager that has to go with the privatized housing. And if you've looked at the news, there are usually challenges that show up every couple months of some occupants that go to the news, and you'll see a press issue that goes there. Oh, we went backwards in slides. That's the one I want. Yeah, I'm talking about that one. Perfect. For the remote remediation to deal with things. But it identifies the roles the facility manager, the facility occupants, or the housing occupants, the managers, and everybody's doing, and also says when you reach out and what bioenvironmental engineering will do. Not telling what to do, but it's really telling the CE folks of, if you have a challenge and you need to investigate this is when we call out to the bioenvironmental engineering folks to come over, take care of things, and make that work. The focus is on prevention and allowing the deterioration to avoid the repair and eliminate health issues. Like anything else, if we take care of it early, you can remediate things. You want to identify that moisture problem before and get to the elevate to the appropriate repair authority with civil engineers, the housing contractors, so they can take care of that within 24 to 48 hours. All of these things are based on the EPA guidance for mold remediation in school commercial buildings as a baseline. It's a really good tool, so that's what we use. And it really says, address this, clean this, vacuum when you need to, and gives you different severity levels of how to address those situations. The key is they identify folks. Identify your leaky plumbing, your leaks. Here's that spot growing in the corner. Let's address that. If you have condensation in windows and walls, we have a common occurrence, especially now that we seal up a lot of our facilities for the energy side. We made the envelope very tight. And if you're here in Panama City, Florida, where you have to turn your defrost on in the morning, and when it's 90 degrees out because you have so much condensation there in your cold window, you get condensation of moisture in strange places. So there's environments that you have that challenge that's there. Another big challenge is the HVAC pans. People go, hey, well, here's that dark spot on my ceiling tile. Well, part of the reason you care about those things is that's where you may have a leak that it may be to that ceiling tile, but it could run down your wall and have other issues. Those of us who got through Hurricane Michael here in Panama City, we had the challenge of moisture in the house, and people who'd evacuated come back a week or two later. All the water moisture that came down ran inside your walls, and your drywall got contaminated. You had the fungi and had to go there. I had a condition of my house where I was running my dehumidifier after the hurricane that I did there and cleaned it up, but I did have to remove my walls. But my conditions were I had less fungi growing on the walls and the interior side than several neighbors who couldn't get to their things. So we were able to clean some of that up, and our mitigation was a lot easier. So while we still had to rip out drywall to make sure the interior was there, the treating of the wood studs and other challenges were less painful than some other occupants in the area as well. Next slide. So as I mentioned, LUD, one of the things that I had the opportunity to do a few years ago was I had to do the Air Force follow-up to the DoD IG inspection over there in LUD, and then continue on to look for similar processes at Ali Salim. And one of the things that we noticed when we were doing the follow-up and looking at the initial report, one of the challenges you have in the deployed locations is you have facilities that go from expeditionary, you're in your tent, those run relatively well, you have a vent, and they're pretty wide open, they're not sealed up, to your permanent construction, which is where we had some of the problems at LUD as well, and places in between where they had some of their shower shave units or facilities that were built didn't have a lot of ventilation in them, and you have a lot of showers and the moisture was there and they weren't clean and you had challenges. So one of the challenges you have there is overseas we have things that were a 5-year temporary building that we're now on 15 years, and things just deteriorate. The roofs aren't repaired and things are there. So those are challenges that have to be looked at from a concern to make sure we stay ahead of that potential. Most people on especially in the Central Command theater, you're there 12 months or less. So whether it's a 12-month tour, whether it's a 6-month tour, 3-month tour, you're still, yeah, I'm here, but I'm not really here. Do I really care? The next guy will get it. We'll write down the note, the next term we'll do it. And then that just moves on to years later and the condition gets worse. The other challenge is the clear delineation for responsibilities for maintenance repair. Because of the nature of our contract support over there, you may have a public works or civil engineer function that's assigned, but the sustainment of the dorms and other places may be a different contract. And how you report that there at LUD was a case of the building that you were staying in your room was managed by the Basai contractor. However, they had to report the other longer term repairs because it was a permanent facility back to CE to go fix. So it was a confusion of who do you call, who do you not. There's certain things that people did so that some things don't get there. The other challenge is when you're in those lousy situations, you do enough times, people just learn to embrace the suck, and I'm not going to complain, or nobody's going to hear, and so it just never gets fixed and continues on. Another challenge we saw over there for one of their mold issues was they had poor construction on the host nation when they built the command center there. Well, the chill water lines were not properly insulated, or they were not properly sealed to the pipe. So there was a gap, and so you got a water trail that came along, ran underneath on the condensate from the chill water, run down a corner and drop on ceiling tiles and bolt behind walls, and people wouldn't take care of it. And you had a whole moldy condition that you didn't take care of that. Well, the root cause is fix the insulation. Well, I can't shut down that facility to allow the contract abilities to get in there. So there are challenges with all of those things that you have to go there. So again, people will ignore things and go to the last minute. And then that's where you have some of the regional type. Oh yeah, the design. We had a bathroom design that it took a while for them to figure out that they're having mold in the first floor bathrooms in the dorms. As it turns out, the way the local architect and construction firm did on the bathrooms, on the bathtub, they built a flat ledge and really didn't have a great seal between the tiles. So the water from the showers upstairs would collect, go down the gap, run down the wall, and just sat and collected in the walls between the lower floor dorms, which created a mold condition and had a not unpleasant place. So those are all sorts of challenges we had to take care of. Okay, next slide. So things just to think about from, how do we improve our air quality? We design up front, look for the moisture collection points, try to make sure that we don't create those, have a clear system of reporting for customers and occupants know how to go there. Get everybody educated. If you see something moldy, just call it, get it corrected. If you ignore it, it won't go there. Fix that issue. And as I said, Grandma has had it right in all of our chases after energy savings and buildings and sealing them up. Get out in the sun, in the fresh air, it'll do you good. It's the same thing with our air quality. If we let air flow through, have the ventilation in, keep it sunny, and we're good to go. With that, I will hand it over to Tom Adams and look forward to any questions later. Thank you.
Thank you, Jim. I really appreciate that briefing. And that was a really good way to really talk about your post out there in Florida. So good on you. I'd like to introduce our last speaker, Mr. Tom Adams. He's going to wrap up this webinar and describe ventilation and how it impacts indoor air quality using the IAQ method to mitigate hazards in the workspace. So, Mr. Adams, over to you.
Thank you, Colonel Hammer. Hey, this is Tom Adams. I am the mechanical engineer, subject matter expert at APTEC, and I'll brief you today a little bit on ventilation, the indoor air quality procedure, as it's presented in ASHRAE 62.1. Okay. My apologies to any non-mathematical attendee here. This presentation obviously has some functions and a little bit of mathematics in it. It's for a reason. It's a little bit technical. When we go through the indoor air quality procedure, there are aspects about it that just lend itself to a mathematical explanation. So the indoor air quality procedure is performance-based. Now, most of us do ventilation designs for a living, use the ventilation rate procedure as described by ASHRAE 62.1. It is kind of analogous to a cookbook method. You go through table of charts and find out what your CFM rates are for certain occupancy types, and they give you a CFM per square footage as well. We add all those together and we come up with a ventilation system size, per that ventilation rate method. The IAQ procedure is different. It is performance-based. We need a known contaminant. We need to know the diffusion rate of that contaminant into the space, and we need to have a threshold limit. And usually those threshold limits are given by some OSHA or NIOSH standard, people in authority that know how much of a contaminant a person can be exposed to without harm. And that's the recommended exposure limit. I just wanted to make a note here that UFC 341001, which is our HVAC design UFC that's applicable to all DoD construction, has a little ventilation supplement that requires us, our designers anyway, to use the ventilation rate procedure in ASHRAE 62.1 to set a minimum outdoor air requirement. And the word minimum was just recently added because ASHRAE 62.1 explicitly states that procedure, the ventilation rate procedure, sets a minimum or floor for ventilation for a space. So that means we can't go below it, but it doesn't mean we can't go above it either. We certainly can. If warranted, we can go above it. So I just wanted to point that out. So this is ventilation for airborne contaminant mitigation. We use a first order linear differential equation to go ahead and solve our problem. And we come up with a function that helps us to size our ventilation system. And the reason that we have to go that route is back in 2015, I was first approached by a design at Hurlburt Airfield, for Hurlburt Air Force Base. They were building a fuel cell maintenance hangar. And the Corps project engineer from the Corps of Engineers gave me a call and said, well, how big a ventilation system do we need? He wasn't quite sure because the hangar itself was a little bit different size than your typical fuel cell maintenance hangar. So they didn't know if they could just, interpolate based on that size, go down a little bit, but they wanted more of an explicit method. So we looked at the ASHRAE indoor air quality procedure, kind of pointed us in the right direction, and we went ahead and used the procedure I'm about to describe to calculate how big a ventilation system we need. And it worked out pretty well. We're going to go through an example here to show you how it works, but also want to make mention that we can also use the same method to control hazardous concentrations in occupied spaces. And I put down on my slide CO2, but that's not the only thing that enters spaces, occupied spaces. You have VOCs and other contaminants from furniture, off-gassing from your printers. There's all kind of different hazards in an office environment. And most of them are fairly mild, but they can be concentrated in some areas. So we're going to see how that applies to that area as well. So here we have a little bit of a description for our fuel cell maintenance hangar. We have essentially what the workers do. They'll pull in an aircraft and pull out the fuel bladders. Well, invariably, there's going to be some spillage from those bladders onto the floor of the hangar floor, and that fuel spill will obviously off-gas into the space. Okay, so I depict here a liquid fuel spill. It's diffusing into the space. We have, the amount coming in, Q dot in. That's the fuel vapors entering the space. We put an exhaust fan in there, so we have a Q dot going out. That's the mass and quantity exiting the facility. And then we have a change of rate. What's our differential term, dQ over dt. That's the rate of change of the concentration in the space. And that's what we're after. We want to know what that is. Okay. Go on to our next slide. We need to know, obviously, some constants. I give them here for JP8. We have to make some assumptions. We'll assume, 1% of the hangar floor has a fuel spill on it. We didn't have any known rate of diffusion into the space for JP8 or jet fuel in general. And so our project manager from the Corps of Engineers did a little test. He set out a large pan of JP8 fuel and measured it over the course of time and found out how much was left, and we used that as our going fuel diffusion rate. Seems to work well. It agreed with other numbers that I found in literature for a similar type problem. So here I give you the constants if you're interested in looking at all of that. And I'm not going to go so much through all the mathematics here. That can be an academic exercise if anybody wants to really take a look at it. I use these slides from a mechanical engineer training course I put together on ventilation systems. And so I'll just leave it for you to go through and take a look if you're really interested in how to turn this crank. Okay. Move on. The big number here is we, go ahead through the method and come up with a CFM rate. Here we calculated for this particular problem 80,000 CFM. That was the size of our system that we needed to put in this particular fuel cell maintenance hangar at Hurlburt Field. We can go ahead and generalize that number a little more and figure out what is the CFM per square foot of hangar floor space. And when you go ahead and do that, you come up with about
Hi, Tom. I believe we lost audio.
I can confirm on my side. I no longer hear him as well.
Jim, are you able to finish? Oh, no, I think we're getting Tom back on. Let's see.
Loud and clear. Yes.
While we are getting the audio fixed, if anyone has any questions, we encourage you to ask those questions in the Q&A tab in your toolbar.
Okay, Tom, over to you. We can hear you.
I cannot hear him on my end. If anyone else can confirm that.
Yeah, I can't hear him either.
Oh, wow. Okay.
If Tom, if you could dial in using your phone again, I think that would help.
Yes, somebody's got the question. We're working on getting the speaker back. Let's see. I think where Tom was in the slides. Did we get Tom back yet?
I hear him dialing in, but I think he's having
okay.
difficulties. Tom, I can hear you. No one else can hear you.
I think he's just connecting on his phone. I see that his icon has changed. Can we get a test, Tom?
okay.
There we go. I can
now?
hear Tom. Yes, and I can too.
Can you hear me? All right.
Yes.
I apologize to everyone having audio difficulties here. My cell phone just cut out on me. Don't know why. Okay, we're still on slide 8. Let me pick up with that. Again, we calculated 80,000 CFM. We divide through by the square footage, and we come up with about 1.7 CFM per square foot. And you'll find that our UFC on aircraft maintenance hangars has this value listed, so we don't have to go through and recalculate how much ventilation is required for a fuel cell maintenance hangar. We just use the 1.7 CFM per square foot, and that'll just give you a little insight on how that's calculated, how we come up with some of these numbers in our policy documents. Moving on to the next slide, it seems to be frozen. Okay, oh, there we go. There's also an alternate way we can go ahead and calculate this number. We can just go ahead and use the perfect gas law and calculate the CFM directly. This gives us a little bit less information than going through and using the first order differential equation method to solve it, because here we just calculate, the size of our ventilation system. It doesn't give us any more information than that. Okay, and you can turn the crank on this method too if you want. But when you use the former method that I showed, you can actually generate a performance curve. And this gives you some good information to show you how strong your ventilation system is, how fast it purges the contaminant from your airspace. And here we see that, we have an instantaneous 1% fuel spill on the hangar floor. It starts to off-gas jet fuel into the space. We turn on our 80,000 CFM ventilation system, and we can track the concentration as it grows into space and seems to terminate at right around 15 parts per million, which is below the 16 parts per million that we want, which is good. We say remain below the recommended exposure limit. And we could also go ahead and instantaneously clean off our fuel spill, at the end of 4 hours, keep our ventilation system on, and it will show us how fast the contaminant is purged from the airspace. It also gives us some good information. So we have that going for us when we use the first order differential equation method. Now, this indoor air quality method, can also be applied to any airborne hazard or contaminated space. We have used the same process to generate how big of ventilation systems are needed for natatoriums, an indoor pool, basically enclosed pool. That's off-gassing chlorine from the pool surface. We can also use it to generate our ventilation requirements for VOCs from paint booths, any type of hazard that our laboratories use. We can go ahead and size our ventilation systems there. And it also can be applied to contaminated office spaces. Let me just say, all office spaces have some sort of contaminant in them. It could be, like I said previously, VOCs from furniture, carpets. It could be pathogens, as the case we were dealing with the COVID-19 pandemic. Had hundreds of questions from the field on how to operate our HVAC system during that pandemic to make it safer for occupants. Also, we have CO2 from human respiration, and that has been studied quite a bit. And we find that concentrations above 1,000 parts per million can actually be slightly harmful. Now, the recommended exposure limit for CO2 is 5,000 parts per million. And I don't think we have a space that gets that high. You have some very, definitive, it's like physiological problems that start to happen at 5,000 parts per million. And you probably have a little bit of oxygen deprivation going on with it, since the CO2 is displacing oxygen as well. So we're not near that level, but even at lower levels, we do have cognitive performance degradation going on. We have headaches, sleepiness, other office ailments that happen when CO2 levels start to rise. So I just offer this. I'm not a medical expert, and I'll leave it to the experts to take a closer look at that, but that could be a problem. So here's a physical depiction in the office space. As Jim mentioned earlier, we have a DOAS system that's bringing in our outside ventilation air. Essentially, it's just acting as a giant dehumidifier. It is pulling in all of the ventilation air that we need, cooling it down, dehumidifying it, and then heating it back up and dumping it into the space. Our primary HVAC system we have here is a 100% recirculation system. It's just handling the sensible load, the load that from the heat outside, from solar exposure, et cetera, those types of things. And here we have people inside off-gassing CO2. They're breathing, so CO2 is entering the space. We have carpets in this particular example, and they're giving off volatile organic compounds of several types of organics, benzene included, other things. And so we can apply this indoor air quality method to this situation. But as I pointed out in the beginning, you know, we need the hazard. We need to identify the hazard. You know, what is that? What are we going to use? Is it going to be CO2? Is it going to be a VOC? And what type of exposure limit are we going to set? You know, if we use CO2 in 5,000, then, you know, the ventilation rate procedure that ASHRAE 62.1 gives is perfectly adequate. But, you know, there's other problems that happen at lower concentrations that we probably need to be a little bit more concerned about. So I did a little looking at the CO2 concentrations from spaces that are sized with the ventilation rate procedure in ASHRAE 62.1. And what I find is that the CO2 levels are very inconsistent. So it does not appear to me that the ASHRAE 62.1 committee used CO2 levels to set those ventilation rates in the ventilation rate procedure. They're all over the map. They range from somewhere around 700 ppm, which is good, very good, all the way up to about 2,500 ppm. And they get particularly high when you look at conference rooms, when you look at auditoriums, when you look at classrooms, where you have a dense population of people with a lot of respiration going on, and you're going to find elevated CO2 levels. And so if you wonder why you get sleepy in a very packed in conference room that drags on for 2 hours, now you know why. The CO2 levels are getting very high, most likely. And
Did we lose Tom again?
I think we
Yes, I
lost Tom
believe
again.
so. Yeah, I think his
All
phone
right.
cut out.
We can
Go
go to.
ahead, Jim.
I'll finish up his stuff for him because his phone's probably there and we're getting close to the back end. Yeah, and as Tom's point is, ventilations are life health safety systems, and we highlighted that in the COVID-19 pandemic. He and I were answering lots of questions. A lot of people are coming up with the ideas. And this is where we're looking at trying to rethink how we look at things instead of the ventilation rate procedures as minimum to address our things. So we think as we've chased the energy curve for years, we need to rethink how we look at our ventilation calculations up front to make sure we properly ventilate the world. And as you said, there's no independent criterion. ASHRAE is not an authority having jurisdiction. The public works are, CE's not one, safety's not the person. It's a collective answer of how do we get to the right place to look at that, and that's been part of our challenge of who becomes the right person to say the right solution.
Am I back?
Yep, you're back. I just got you through your conclusion, Tom. I'll let you reconclude if you want.
Yeah, well, no, you did great, Jim. Thanks for picking up. I apologize again. The phone just cut off on me again. Actually, the last two bullets, Air Force Safety, Air Force SG, I just put a question mark there. Are those the responsible people? Are they the people having the authorities having jurisdiction in this area? Should they be the ones that set indoor air quality criterion for our office spaces? I am not. So, any proposal that I would give, people would look at me and say, you're not, an expert in this field. And they're right. I'm not a biomedical officer of any sort. My training has been mechanical engineering, you tell me the criteria, and I'll build you a mechanical ventilation system to meet that criterion. So this is really a handoff to someone else. Should someone else pick this up, perhaps Aerospace School of Medicine, perhaps some safety office in DOD, Air Force, Army, Navy, could be anyone. There are AFIs out there that in which the safety office and the SG, look at ventilation programs and systems, and they set criteria in there. So I'm just asking, should they look at indoor air quality requirements for office spaces? And with that, I think I'm done. Thank you for your patience.
Thank you very much, Tom. Thank you, Jim, and thank you, Alan. Very, very good briefing today. Just describing, at least on the Air Force side, how we address indoor air quality. I know we are at the hour point. I want to thank the attendees who've taken the time to spend this hour with us. Tamel, if you don't mind, I'm going to, I think we're over. I don't know if this is going to end on us. Tamel, would you be able to let me know that real quick?
I'm sorry. What were you
We
saying?
have one question. Oh, I was wondering, we're at the hour mark. Will this end on us? I just want to try to get through this one question by Chris Belmont.
Yeah, no,
and then any others that.
We have time to get through it. It's not going to cut us off.
Okay. Well, if anyone can stay on the line, we're going to answer this question here. And if there are any other questions that pop up, we can address that as well. I don't know if the speakers can remain. I think Tom might have somewhere to go. But Chris Belmont asks, for occupied and older facilities, do you find it more effective to install a sub-slab system or a fan system? So I'll hand that over to any of the speakers. That came in early on, so probably a radon question, maybe followed up by an HVAC 1, 2. Over.
This is Alan so sometimes radon usually comes from the soil and is permeating up into the facility. It can come from bricks and concrete that the facility is made of. So ideally, you would want to seal the slab in an underground foundation, and then put a fan puncture the slab and then vent it out so it doesn't enter the workspace. However, some facilities may not be able to be fully sealed or impossible, or if it's a large facility, particular areas of the facility could have local exhaust to control the contaminants in that facility. I can turn over to Tom and Jim for some practical experience.
Yeah, we actually get this. I had this question recently from Aviano because they have, as the host country when they're doing the projects, want to deal with some of our renovations to address the radon issues there. And again, if it's new, yes, we'd go a sub slab. Most typically, you will use, because the cost-effective solution is your basement level exhaust fan system. You can get those. And when I moved down here to Florida from Connecticut, I had to put one in my house up north because I just had one that was growing in my 30-year-old basement. And you can get those relatively low cost because the object is to get the contaminant out, vent it out. It's not like other things that you have to treat on the way out. So with your older ones, it's typically you're going to have a capture point somewhere at the low point of the facility and put a big enough fan to get suction to exhaust a contaminant out.
First, I might just want to add, this is Tom Adams, that the EPA has a standard design for these systems. And so if you search on the EPA website under radon mitigation, you'll find some documents there that might help you out, and they coincide exactly what Jim said. They're mostly under slab, some type of crawl space or gravel space that you're venting. All of them will require a fan to forcefully exhaust whatever's captured or released underneath.
Excellent. Thank you all for answering that question. Chris, I hope that that helps you out. You should have the presenters' email addresses if you want to contact them directly. I think that's okay to do. I'll give some folks time to ask more questions, and in the meantime, I just want to put a plug in for the Health Engineering Task Force. There is a health related track at the upcoming facilities management workshop. In fact, Mr. Jim Works will be presenting one of the 4 topics. So we hope to see you there as well. Also, the Health Engineering Task Force is still in the task force status, working on becoming a community of interest. As you can tell by today's topic, this is where you can see the health-related engineers. In the Air Force, we're called bioenvironmental engineers, as well as preventive medicine staff or personnel. You can see where we really converge with our civil engineers and facilities and infrastructure, and where we can really solve some issues, whether it's health, and whether we can implement any types of controls, whether it's HVAC or things like that. You can see where the health and the civil engineers come together, as well as in SAME. And that's the purpose of our Health Engineering Task Force, bringing this health aspect, subject matter experts to the society. So if you'd like to join us, we meet every third Thursday at this hour. You can find us on the COI website under Health Engineering Task Force, and you can join us there. So I'm going to take a look and see if there are any other questions here for us. I don't see anything here. I do want to also, with respect to Mr. Adams' briefing, where he does have a question about that standard and who really should own and maybe work out a standard for IAQ ventilation rates for the office space. He did mention that there really is none at this time. And I saw a question mark. Should it be safety? Should it be the SG, which in the Air Force are the bioenvironmental engineers? I think based on this task force and having other experts in the other COIs, I think maybe it might be appropriate for SAME to also take a look at this and come up with some type of criteria, maybe in some roundtable or something like that. So if we have anyone from the facilities COI who might be interested in chatting with us about this, we certainly are open to that and maybe a roundtable type of forum. Okay.
This sounds like a great industry government. This sounds like a great industry government engagement topic for SAME.
I agree. Yes, exactly. And I would love to explore it on the SAME side, and as well as the Air Force side. I think that's a very appropriate and very relevant topic for us to take a look at. So there are 2 options there. Okay. Anything else? I don't see any other questions here, and I know we're over the time now, so we may have lost a few folks. So with that, I am going to end this webinar at this time. So thank you very much to Alan, Jim, and Tom. Thank you also to all of those who attended this webinar. The Health Engineering Task Force will be providing quarterly webinars, so stay tuned in August for our next webinar. Thank you to Mel always for your support, Rob Reederman as well. So with that, we will see you next time. Thank you very much.
Thank you, Colonel Hammer.
Here. Thank you.
Thank you. Thanks all.